The transition from uncoated to tinned copper in Type W cables is a recent change in the industry, and there are several potential concerns to consider. Firstly, the tin coating can slightly reduce the electrical conductivity of copper. This reduction, though often minimal, can impact voltage drop calculations, especially over longer cable runs or with higher current loads. Secondly, tin provides better corrosion resistance than bare copper. This characteristic can be beneficial in damp or corrosive environments, extending the lifespan and reliability of the cable. Thirdly, tinned copper may require different connectors or terminals to ensure proper contact. The tin coating can affect the friction and electrical contact between the conductor and the connector, so using appropriate connectors is crucial. Whether to use the coated resistance column in National Electrical Code Table 8 for voltage drop calculations depends on the specific cable. If the cable is specifically labeled as tinned copper or annealed tinned copper, using the coated resistance column is essential for accuracy. If the cable is not explicitly labeled, it is best to consult the manufacturer's specifications or refer to industry standards such as Underwriters Laboratories 493 for guidance. Several additional factors can affect voltage drop. Larger cable sizes generally have low voltage drop, regardless of the coating material. Selecting an appropriately sized cable based on the expected current and distance is paramount. Proper installation practices, including tight connections and avoiding sharp bends, can minimize voltage drop. Loose connections create resistance, and sharp bends can damage the cable, both of which contribute to increased voltage drop. Understanding the voltage tolerance of the equipment being supplied is also crucial. A slight increase in voltage drop due to the tin coating may not be an issue if it remains within the acceptable operating limits of the connected equipment. To ensure accurate voltage drop calculations and optimal performance, it is recommended to 1. Always use the coated resistance column in National Electrical Code Table 8 if the cable is confirmed to be tinned copper. 2. Consult the manufacturer's specifications or contact a qualified electrician for detailed guidance specific to the cable and application. And 3. Carefully consider the voltage tolerance of the equipment and the potential impact of any calculated voltage drop to make informed decisions about cable selection and installation practices. Remember that accurate voltage drop calculations are essential for ensuring the safe and efficient operation of electrical systems. Overestimated voltage drop can lead to equipment malfunction, reduced performance, and potential safety hazards. In addition to the above, consider the following points. The impact of temperature on cable resistance is significant. As the temperature of the cable increases, its resistance also increases. This means that voltage drop will be higher at higher operating temperatures. National Electrical Code Table 310.15b16 provides ampacity correction factors for temperature, which can be used to adjust the allowable ampacity of the cable based on the ambient temperature. For accurate voltage drop calculations, it is crucial to use the resistance values corresponding to the actual operating temperature of the cable. The length of the cable run is a critical factor in voltage drop calculations. Voltage drop is directly proportional to the length of the cable. Therefore, longer cable runs will experience greater voltage drop. For long cable runs, it may be necessary to increase the cable size to compensate for the increased voltage drop. The current flowing through the cable is another significant factor. Voltage drop is directly proportional to the current. Higher currents will result in greater voltage drop. It is essential to accurately determine the maximum current that the cable will be carrying to ensure that the voltage drop remains within acceptable limits. The power factor of the load also affects voltage drop calculations, especially in alternating current circuits. Loads with lower power factors will draw more current, leading to higher voltage drop. It is important to consider the power factor of the load when performing voltage drop calculations. The type of load also influences voltage drop considerations. Different types of loads, such as resistive, inductive, and capacitive loads, have different characteristics that affect voltage drop. For example, inductive loads, such as motors, can cause significant voltage drop during startup. When performing voltage drop calculations, it is crucial to consider the specific characteristics of the load being supplied. The National Electrical Code provides guidelines and formulas for calculating voltage drop. Section 210.19 A1 provides requirements for branch circuits, and Section 215.2 A3 provides requirements for feeders. These sections specify that the voltage drop on branch circuits should not exceed 3% and the voltage drop on feeders should not exceed 5%. Following these guidelines will help ensure that the voltage drop remains within acceptable limits. Several online voltage drop calculators are available, which can simplify the calculation process. These calculators typically require inputting the cable size, length, current, voltage, and power factor. Using a voltage drop calculator can help ensure accuracy and save time. Regular inspection and maintenance of electrical connections are essential for minimizing voltage drop. Loose or corroded connections can significantly increase resistance, leading to higher voltage drop. Periodically inspect all connections and tighten or replace them as necessary. Consider using a 4-wire system instead of a 3-wire system for long cable runs. A 4-wire system provides a separate neutral conductor, which can help reduce voltage drop. This is especially important for unbalanced loads. When installing cables, avoid sharp bends, which can damage the cable and increase resistance. Use proper bending techniques and tools to ensure that the cable is not damaged during installation. Use cable trays or conduits to support and protect cables. This will help prevent damage to the cables and ensure that they are properly supported. When selecting cables, consider the environmental conditions in which they will be used. Factors such as temperature, moisture, and exposure to chemicals can affect the performance and lifespan of cables. Choose cables that are specifically designed for the intended environment. When connecting cables to equipment, ensure that the connections are properly torqued. Over-torquing can damage the equipment, while under-torquing can result in loose connections. Use a torque wrench to ensure that all connections are properly tightened. Use high-quality connectors and terminals. Low-quality connectors can corrode or loosen over time, leading to increased resistance and voltage drop. Choose connectors that are specifically designed for use with the type of cable being used. Consider using active voltage regulation devices for critical applications. Active voltage regulation devices can automatically adjust the voltage to compensate for voltage drop, ensuring that the equipment receives the correct voltage. Document all voltage drop calculations and keep them readily available for future reference. This will help ensure that the electrical system is properly designed and maintained. Consult with a qualified electrical engineer or electrician for assistance with complex voltage drop calculations or electrical system design. They can provide valuable expertise and ensure that the electrical system meets all applicable codes and standards. Remember that voltage drop is a critical consideration in electrical system design. By following these guidelines, you can minimize voltage drop and ensure the safe and efficient operation of electrical equipment. Consider future load growth when selecting cable sizes. If you anticipate that the load will increase in the future, select a cable size that can accommodate the increased load without exceeding the allowable voltage drop. When running multiple cables in parallel, ensure that they are properly balanced. Unequal current distribution can lead to overheating and increased voltage drop. Use appropriate methods to balance the current in parallel cables. Consider using shielded cables to reduce electromagnetic interference, which can affect the performance of sensitive electronic equipment. Shielded cables can also help reduce voltage drop in some applications. When installing cables in underground ducts, ensure that the ducts are properly sized and ventilated. Overheating can occur if the ducts are too small or poorly ventilated, leading to increased voltage drop. Use cable lubricants to reduce friction when pulling cables through conduits or ducts. This can help prevent damage to the cables and make installation easier. Avoid running cables near sources of heat, such as ovens or furnaces. Heat can increase the resistance of the cables and lead to increased voltage drop. Use thermal insulation to protect cables from heat. Regularly inspect cables for signs of damage, such as cuts, abrasions, or discoloration. Damaged cables should be replaced immediately to prevent electrical hazards and ensure reliable operation. Use appropriate cable markers to identify cables and circuits. This will help prevent confusion and make it easier to troubleshoot electrical problems. Keep accurate records of all cable installations, including cable types, sizes, lengths, and routing. This information will be valuable for future maintenance and troubleshooting. Follow all applicable electrical codes and standards when installing and maintaining cables. This will help ensure that the electrical system is safe and compliant with regulations. Remember that electrical work can be dangerous. Always take appropriate safety precautions, such as wearing personal protective equipment and energizing circuits before working on them. If you are not qualified to perform electrical work, hire a qualified electrician. By following these guidelines and best practices, you can ensure that your electrical systems are properly designed, installed, and maintained, minimizing voltage drop and ensuring the safe and reliable operation of electrical equipment. Consider the use of harmonic filters in systems with significant harmonic distortion. Harmonics can increase the current flowing through the cables, leading to higher voltage drop. Harmonic filters can reduce the harmonic content of the current, thereby reducing voltage drop. When using variable frequency drives, consider the impact on voltage drop. Variable frequency drives can generate harmonics, which can increase voltage drop. Use appropriate filtering techniques to minimize the impact of harmonics. Consider the use of power factor correction capacitors to improve the power factor of the load. Power factor correction capacitors can reduce the current flowing through the cables, leading to lower voltage drop. When installing cables in high-altitude environments, consider the reduced air density. Reduced air density can affect the ampacity of the cables. Consult the manufacturer's specifications for dating factors for high-altitude installations. When installing cables in areas with high levels of electromagnetic interference, consider the use of fiber optic cables. Fiber optic cables are immune to electromagnetic interference and can provide reliable communication in noisy environments. When designing electrical systems for sensitive electronic equipment, consider the use of surge protection devices. Surge protection devices can protect the equipment from voltage surges, which can cause damage and disrupt operation. Regularly test the grounding system to ensure that it is functioning properly. A properly functioning grounding system is essential for safety and for minimizing voltage drop. Consider the use of energy-efficient lighting systems to reduce the overall electrical load. Energy-efficient lighting systems can significantly reduce the current flowing through the cables, leading to lower voltage drop. When selecting electrical equipment, choose equipment with high-efficiency ratings. High-efficiency equipment consumes less power, which reduces the current flowing through the cables and lowers voltage drop. Consider the use of smart grid technologies to optimize the performance of the electrical system. Smart grid technologies can monitor and control the flow of electricity, reducing voltage drop and improving overall efficiency. Stay up to date on the latest electrical codes and standards. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. Follow all applicable codes and standards to ensure that your electrical systems are safe and compliant. Continuously monitor the performance of your electrical systems and make adjustments as needed. Regular monitoring can help identify potential problems before they become serious and ensure that your electrical systems are operating at peak efficiency. Remember that electrical safety is paramount. Always take appropriate safety precautions when working with electricity and consult with a qualified electrical professional if you have any questions or concerns. By following these guidelines and staying informed about the latest technologies and best practices, you can ensure that your electrical systems are safe, efficient, and reliable.